Mine isn't sciencey.
Science puppets.
Mine is related to the imagination.
Oh, yours is not sciencey.
No, I don't have any sciencey puppets at hand.
Is that Puff the Magic Dragon?
No, it's Figment.
Figment the Magic Dragon.
No.
I'm confused.
He's from Epcot Center in Disney World. He's the spirit of imagination.
Oh, right. Okay.
Yeah.
Okay.
Yeah.
It's time to start a show. 3, 2. This is TWIS. This Week in Science, episode number 632, recorded on Wednesday, August 16th, 2017. Sweet magic science! Hey everyone, I'm Dr. Kiki, and today we are going to fill your heads with magic mushrooms, jovial jellyfish, and sweetness. But first...
Disclaimer, disclaimer, disclaimer. Conflict resolution. It's a tricky thing. There are two sides to any argument, often many sides, and many sides may have opposing views that, as the conflict resolution process plays out, may or may not get their way. And according to Dr. Stephen Bruce, by way of the HR Advisor website, there are 6 steps to conflict resolution. 1, clarify what the disagreement is. 2, establish a common goal for both parties. 3, discuss ways to meet a common goal. 4, determine the barriers to the common goal. 5, agree on the best way to resolve the conflict. And 6, acknowledge the agreed upon solution and determine the responsibilities each party has to the resolution. Now, you can use these steps to improve the relations with your fellow citizens. They work, but straightforward conflict resolution has its limits. It may keep Karen at work from taking your parking space, stealing your stapler, or eating your lunch. But if Karen wants you dead, you need another strategy. And while it may be too late to do anything meaningful to change Karen's outlook, you can rest assured that almost every human being on Earth sides with you. And together, we will stop the Karens of this world with This Week in Science coming up next.
Karen!
I've got the kind of mind I can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki.
Can you say that again, Justin?
Good science to you, Kiki and Blair.
And good science to you, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We are back yet again with more science. Oh, what a week it's been. Oh, what a week. I hope that this show brings everyone sciencey happiness, right? There are positive things afoot in the world. And this show is full of them. Oh my goodness. On this week's show, I have stories about magic mushrooms because those are fun. And dinosaur trees. You know, get a cat in a tree, put a dinosaur in a tree. Yeah, no, not exactly. And why you should love Snowball Earth. Yeah, Justin, what do you have for us?
I've got sulfuring from asthma, microRNA cures, and some truth about e-cigs.
Truth. We like the truth. Truth is relative. Anyway, Blair, what's in the animal corner?
I have teamwork that makes the dream work for jellyfish. I have eclipse news as relates to Blair's Animal Corner. And I have terrifying, adorable spiders.
Yeah. Are they dancing? They're only adorable when they're dancing.
They're always dancing in here.
Oh, you got spiders in your head.
Only dancing ones, though.
Oh, no cobwebs?
No. Just
Yeah.
dancing once, you know.
All right. All right. Anyway, we're moving into the show. And as we jump into our new favorite first segment of the show, I want to remind everyone that you can subscribe to the TWIS podcast on iTunes, in Google Play, in the podcast portal, on Stitcher, Spreaker, and TuneIn. We're all over the place. You can also find us on YouTube and Facebook. Search for This Week in Science. Or you can just visit twis.org. But now it's time for This Week in What Has Science Done For Me Lately? Hi, Dr. Kiki. Well, hello. Firstly, thank you for such a wonderful podcast. I live in Queensland, Australia. I often hear Blair mentioning studies from here in Oz. Every week, I look forward to listening to you all delivering science news whilst I'm on the long commute to and from work. I wanted to offer you an insight as to what science has done for me lately. For the past year, my girlfriend and I have been going through IVF. I myself cannot produce mature eggs to use. Therefore, science is intricately involved in our process, whereby she is able to donate her eggs and have them fertilized, and the process of frozen embryo transfer to begin, so that I may one day hope to be a mother. I'm often in awe of the amazing opportunities science offers us in these situations, and I am so thankful for its development and involvement in my life. I understand that that she just wanted to let us know her story and have a side note to say, thank you for your wonderful podcast that enlightens and brightens my week. Keep up the good work. Cheers, Loui. Loui, thank you for writing in. Thank you for sharing your experience with us and what science is doing for you currently. And we look forward to hearing good news about your motherhood. Everyone out there, remember that we need you to write in and let us know about what science is doing for you, does for you on a daily basis. What does it do for you every day? Tell us. Send us a Facebook message. That's right. Go to our Facebook page, This Week in Science, and write us a message, and we will put you in to read your letter. We want to fill this segment of the show with something from you every single week. So help us help you learn how science is making our lives better. And I want to say, this segment of the show, it is one segment of the show that brings a smile to my face. It's a positive every single week. Thank you, you guys. Let's keep it going. Yeah, you guys ready for some science news?
Let's talk about some science news.
Let's talk about snow, baby, and how it may be. Ground all the continents to dust, and then they went to the sea. Anyway, yeah, that didn't work so well.
I think it was going great.
It's all right, fine.
All right. So the next story, my first story of the show, is with regard. It's out of Australia, actually. So it's interesting that our letter this week is from Australia. This news is from Australian National University, ANU, and a researcher there has reconstructed a timeline of life before and after the Sturtian glaciation. The Sturtian glaciation is what we often refer to colloquially as a snowball Earth. It's that period of time about 700 million years ago when glaciers, snow, completely covered the planet from the poles all the way to the equator. Big, giant snowball. This wasn't a partial glaciation. Everything was glaciated. Before that period of time, the planet had a bit of life, but it was single cellular. Bacteria. We had cyanobacteria that were working furiously to convert sunlight into oxygen. But, there was a bunch of stuff going on, and then snowball. Cold. Things were happening. However, it ended, and when it ended, things heated up about 650 million years ago really quickly, and it was like a greenhouse effect happened, and all those glaciers melted. So what happened were the glaciers moved across the surface of the continents, grinding up the Earth, creating a bunch of gravel and dirt and all sorts of stuff that when they melted, they carried it all into the sea. And so a whole bunch of stuff containing nitrogen ended up in the ocean. And as a result of the big dump of nitrogen into the ocean, this researcher and his colleagues, Jochen Brox, he suggests that this allowed for an explosion of multicellular life, and that we moved forward from that single cellular cyanobacteria, very simple life form predominance on Earth, into a more complex predominance. Algae became the prominent photosynthesizers. Algae became the things that fed on the nitrogen that was in the oceans and allowed, because of the blooms of the algae that was feeding on the nitrogen, and also a bunch of phosphorus and stuff that had ended up in the waters, created a bunch of oxygen, and we had a bunch of food and oxygen and explosion of life. And so it was the snowball Earth grinding down the continents, according to this hypothesis, that led to us eventually. But really,
Nice.
yeah, so the Ediacaran explosion that came later was basically a result of all these nutrients being ground down by the glaciers, and then the melting glaciers sending them to the sea, where they would fertilize the development of life.
Snowball Earth. Thanks.
Yeah, and so it's a really interesting. How they figured all this out was pretty interesting. A PhD student working in Brock's lab had found a bunch of old rocks, and so they went about sampling the rocks. And because we're looking at stuff from a long time ago that was under the ocean, that's not under the ocean anymore, and so what they're looking for is fossil evidence of early life, not even fossils of animals with bones and things that you could pick out, but we're looking for chemical signatures. That's what they were looking for. And so looking for these chemical signatures, they were able to find cell membrane biomarkers and be able to, and it enabled them to make this new hypothesis about the development of life.
Yeah, the old hypothesis, as I recall, and I'm probably wrong, was that in snowball Earth, all the single-celled organisms huddled together for warmth, and then became multicellular. No, that's not how.
That's not how they huddled together around the campfire. No.
It was so cold. Come a little bit closer.
No. I have a good name for this story. Brock's Rocks.
Brock's Rocks. That's good. The co-lead researcher was this PhD student, and her name is, excuse me. She is not a student. She is a graduate at this point. Amber Jarrett. Got to give the female geologist her due.
All right. I guess Jarrett's Rocks, although that doesn't sound.
It doesn't sound as good as Brock's Rocks. But Amber Jarrett, she discovered these ancient sedimentary rocks in central Australia, and they led to this discovery. And she says, in these rocks, we discovered striking signals of molecular fossils. We immediately knew that we had made a groundbreaking discovery that snowball Earth was directly involved in the evolution of large and complex life. Directly. Snowball Earth to you. That's right. Moving on, another Australian story. 400 million year old fish jaws were being researched again by Australian National University PhD scholar Yusri Zhu from China. This study on this 400 million year old fish fossil has been looking at its jaw structure. I mean, the reason they're looking at these placoderms, these armored fish from 400 million years ago, is really to figure out, look at it, figure out what traits were there. How did the evolutionary lineage pan out? These placoderms came prior to tetrapods, the four-limbed creatures that eventually led to us. It all comes back to us, right? This is what my stories
Yes,
are
but
doing.
how am I involved?
Yes, well, you are involved because they have found a jaw structure in this ancient fish. It was a pretty major structure in this fish, but now it's like this little tiny thing. So this joint in the fish is in the human skull. It has been conserved, but it's in your ear. It's not in your jaw anymore. It's in your ear. And so there is a direct linkage between you, Blair,
Yes.
and this 400 million year old fish. Anywho, these researchers have been trying to figure out more about these extinct placoderms, and they've been traditionally thought of as kind of a side branch of evolution, not really one of the main branches, but Chinese researchers have they found, or our paleontologists have found Chinese maxillate placoderms. Maxilla, that's like in your upper jaw. It's a fossil group that's researched in Beijing by this researcher, Jing Liu, before she came to this Australian university. And Dr. Liu says the maxilla is the bone that forms the upper jaw in humans. Chinese fish fossils have this bone, demonstrating a much closer relationship to human ancestry than previously thought. But other internal structures were apparently made of cartilage and are not clearly preserved. And this particular fossil was very well preserved. And she says that the Australian fossil helps us to interpret these aspects in the Chinese maxillate placoderms. So the big thing about this one is that there was a lot of the cartilaginous structures that were preserved that are allowing them to really take a look at this group of bony fishes from long ago. And it's published in scientific reports. And then moving forward from jawed fishes, let's move right into dinosaur trees. I mean, family trees. I'm not putting dinosaurs in the trees, I tell you.
You had me, you lost me, and then you had me again.
There you go. That's what I do. So the dinosaur that I am talking about is called Chilesaurus. Chilesaurus diegosuarezii. I really like this dinosaur's name. And in its original description, there was a paper that came out earlier this year describing this dinosaur. It's considered a tetaneuron theropod. Theropods are also like T-Rexes and other of those dinosaurs that stand on two legs. Yeah, with their small arms in front. But it was kind of, people started referring to it as a Frankenstein dinosaur because it had a lot of these theropod characteristics, but it wasn't quite theropodish. And this new study that is just out in Royal Society Journal Biology Letters suggests that it's not actually a theropod. That what it is a missing link between...
Oh, that's better.
A missing link, yes. And it's a missing link between a group of dinosaurs, the ornithischians, containing stegosaurs, and the carnivorous dinosaurs like T-Rex. It's right in the middle between the plant eaters and the carnivores, or the meat eaters. I mean, it's argued that T-Rex is a scavenger. But anyway, so this new study, Matthew Barron, who's a PhD student at Cambridge University, he said that he first thought that this was an ornithischian, but then there was a bunch of stuff and they're like, well, this isn't quite right. And so he says, we had absolutely no idea how the ornithischian body plan started to develop because they look so different to all other dinosaurs. They have the bony plates along their back and they have so many unusual features. And they've never had a concept of how the first ones could have looked until now. And then this discovery of this Chileosaurus show it has legs. It stands on very thick legs of an animal like a brontosaurus. It has hips like a stegosaurus, and the arms and the upper body of something like a T-Rex or a raptor. and they didn't know quite where it fits. So we've got all these hodgepodge of parts.
And what are they calling this thing?
So now they are calling it part of the Ornithischian group.
Okay.
They have redesigned the cladogram. They've redesigned the family tree for these dinosaurs and have put it firmly in the branch between stegosaurs and T-Rex. So it has bird limbs to one degree, but also plant eating to another degree.
This is the Chilosaurus?
The Chilosaurus.
Very cool. Was it found in Chile?
Yes.
Okay. Nice.
Yeah. So this new family tree, while still under debate and controversial, is called the Barron tree for Matthew Barron, who drew it. Yes.
So he has a cladogram named after him, which may, after some more findings, never exist again.
Yes, exactly. We'll wait for some more findings and we will see. But really, this understanding where to put these animals kind of it helps us understand a bit of the driving factors at play in evolution. What happened to split the stegosaurs to the T-Rex? What happened and when? And so it's very interesting. So Chileosaurus, no longer Frankenstein, now a missing link.
Very cool.
Yes. Yeah. Bringing together, I love it, bringing together the stegosaurs and the T-Rexes, spanning the gap.
Yeah. If they can do it, so can we.
That's right. This is This Week in Science. Hey, Justin, what you got?
I have this is a heavily local story. It's California, Europe. Elemental sulfur, most heavily used pesticide in California, Europe, may harm the respiratory health of children living near farms that use the pesticide. This is according to new research by UC Berkeley. Elemental sulfur is allowed for use on conventional and organic crops. It's used to control fungus, other pests. Very important element in farming. California alone, more than 21 million kilograms of elemental sulfur were applied in just a single year. Studying children in the agriculture community of Salinas Valley, California, researchers found significant association between elemental sulfur use and poorer respiratory health. The study linked reduced lung function, more asthma-related symptoms, and higher asthma medication use in children living a half mile or less from recent elemental sulfur applications. So currently, the EPA generally considers elemental sulfur as safe for the environment and human health, but previous studies have also shown that it's a respiratory irritant, mostly affecting, of course, farm workers who are right up close to it. Effect on residential populations, though, especially children living near treated fields, studied until the study that was published August 14th in the journal Environmental Health Perspectives. Sulfur, this is quote voice of co-author Asa Bradman, Associate Director of the Center for Environmental Research in Children's Health at Berkeley School of Public Health. Sulfur is widely used because it's effective and low in toxicity to people. It is naturally present in our food and soil and is part of normal human biochemistry. But breathing in sulfur dust can irritate airways and cause coughing. We need to better understand how people are exposed to sulfur used in agriculture and how to mitigate exposures. So still needs to be used, but he's sort of indicating there's maybe another way to put it into the soil or apply it to the crops so that it has the beneficial effect without the negative. For the study, the research team has examined associations between lung function and asthma-related respiratory symptoms in hundreds of children living near fields where sulfur had been applied. A 10-fold increase in the amount of sulfur used within a kilometer of a child's residence during the year prior to pulmonary evaluation was associated with a 3.5-fold increased odds in asthma medication usage and a 2-fold increased odds in respiratory symptoms such as wheezing and shortness of breath. The study also found that each tenfold increase in the amount of elemental sulfur applied in the previous 12 months within a 1 kilometer radius of the home was associated with an average decrease of 143 milliliters per second in the maximal amount of air that the 7-year-old children could forcefully exhale in 1 second. So that number standing by itself may not seem like much, but for comparison, that 141 decrease, they compared it to what researchers showed in exposure to maternal cigarette smoke, which is associated with a decrease of 101 milliliters per second after 5 years of exposure. So, mom's smoking for 5 years, actually almost as, but not quite as bad as living near a farm where sulfur is being applied, according to this study. The study provides the first data consistent with anecdotal reports from farm workers. It shows that residents, in this case children living near fields, may be more likely to have respiratory problems from nearby agricultural sulfur applications, says senior author Brenda Ezeknazi, Berkeley professor at the School of Public Health. Given elemental sulfur's widespread use worldwide, study authors call urgently for more research to confirm these findings and possible changes in regulations, application methods to limit impacts of sulfur used in respiratory health. So, and this study was these kids in this study too were, they made a good effort to remove smoking in the household, age factors, these factors, lots of other factors within the household that could have led to these. However, these are mostly the children of farm workers because they tend to live closest to farms. I think most of the population lives far enough away from a farm that they wouldn't be affected by this. So one solution could just be create a regulation that makes it so you can't have residential housing within half a mile from a
That's so hard to do, though. I mean,
the Central Valley.
Growing up where I grew up, there's fields, and then there's a road that goes next to the fields, and then there's houses on the other side of that road.
Yes.
I grew up in the middle of fields.
Yeah.
My house was in the middle of them.
And the Central Valley is the only place where they're adding housing is they're taking over farmland, which means that, like in some places, housing encroaches on nature. In California, housing encroaches on farmland. So as we build more homes, we become closer to the farmland and we'll be exposing more and more children in greater numbers to what goes on the farm. So the applications method, that's probably where they need to concentrate.
There's another study that came out related to health indicators and pollutants. And so really fine particulate matter pollutants seem to increase stress hormones and also increase other hormones and metabolic factors. So could be part of the kind of negative health cascade of some individuals in areas where pollution is. And so maybe something related to the particulate size of this elemental sulfur, the sulfur being in the air, being in the water, are they breathing it? There are more questions to be answered here, but obviously there is something going on that needs to be addressed.
And it kind of also just goes to show there's nowhere safe. You move out to the farmland.
That's why I want to go back to where the farms are. It's so nice.
Go to the heart of the urban area, asthma. I'm going to move up into the mountains, up in the forest, and then you get the forest fires and you get asthma. Like,
there's nowhere safe to breathe anymore.
So maybe a ship at sea. That's what we'll do with the children. We'll put them at sea until they're old enough to develop their lungs.
Yeah, that's feasible. Nope. Nope.
Life Aquatic for all you young pirates.
Oh, I do love that movie. But you know what? It's not time for that right now. Yeah. You know what it is time for?
What's it time for?
Blair's Animal Corner.
She loves our creatures, great and small. Biped, millipede, no pet at all. Wanna hear about
about animals. She's your girl, except for giant pandas and squirrels. Animal corner.
What you got, Blair?
I'm so glad you asked. Well, I wanted to start tonight with some very special animals with some very special teamwork. Those animals are called salps, S-A-L-P, salp.
That wasn't the animal I was expecting you to say.
Oh, that's
Salps.
right.
Salps.
Salp. People mistakenly call them jellies, jellyfish, because that's what they most look like. But they are, in fact, tunicates, so they're not related to jellyfish. But they and another organism called a siphonophore, which are related to jellyfish, those are also known as Portuguese man-o'-war. They both are colonial organisms that move as a group. And researchers wanted to look at exactly how they get that done. So this is actually from the University of Oregon, and marine biologist Kelly Sutherland with her team looked at these salps and siphonophores in the ocean on the Pacific Island, on a Pacific island just off of Panama, and they used high-speed, high-resolution underwater camera systems to study their propulsion. The reason they wanted to do that is that there's something really unusual about the way these little animals move. When you look at jellies, at jellyfish, the way they move, it's interesting because it doesn't seem to take very much energy. In fact, they're technically plankton. Plankton is not necessarily tiny. Plankton is something that moves with the currents. So jellyfish, they don't use that much energy to move, and they kind of do this pulsating movement. The thing about that is that during the pulse, they move quickly, and then they almost lose distance while they're kind of bringing their body back up to its biggest form before they push it back down to propulse again. So it's clunky because it's inconsistent. They're not using momentum. They're speeding up and slowing down and speeding up and slowing down. What's interesting about salps and siphonophores was that they appear to maintain a constant speed, but they move the same way. So siphonophores, again, they're related to jellies. So they move the same way as jellies do, kind of by moving a bulb. The salps move by pushing water out of a funnel. So kind of like how you might see a squid move. But the way it looks a lot like how a jellyfish moves. But when you put them all together, they move at a constant speed. They don't start and stop and start and stop. Yeah, Kiki's showing an amazing video that kind of shows you how it looks like it's being run by an engine. And that's exactly where this research kind of led to, was looking at these salps and siphonophores as related to a jet propulsion engine. And what they found is that in these chains or colonies, which can be up to 15 feet long, they actually all fire their siphons at different times, at random times. But the way that it's done allows for a constant push and no pull. So this is the most efficient way of moving through water we've ever seen.
Okay, so that's pretty neat. So they're doing this as a group. It's like if we all got into a pool together and I kicked for a minute, then stopped, and then you kicked for a minute and stopped, and then you kicked for a minute and stopped, and then we'd keep moving.
Except it's not kicking; it's the human equivalent of a jet engine.
Right.
Yeah.
So imagine if you were moving by going,
working as a group,
just blowing air out of your mouth fast enough that it pushed you backwards. But then you would have to go, and that might slow you down or even pull you back from where you came from. And then you have to go, and that'll push you back again. But they're doing this push, pull in this uncoordinated yet coordinated method so that they actually move steadily without a loss in energy. So one thing to be mentioned is that in the salps, the way it works, they actually are found in chains or colonies, and they have this solitary life stage that produces the interconnected colony. So a lot of the individuals, if not all of them, are genetically related. So that means they have a good reason, motivation, whatever it be, to work together. And that's how the Portuguese man o' war works too. It's the same organism in 3 different developmental stages living at the exact same time.
And I mean, I just Googled these things. I'd never heard of it before. It's saying here that they're clones?
Yes, exactly. That's what I was saying. So the colony...
Not just closer related. They're like the same...
Yes, exactly. So there are similarities here to things that we talk about in the development of the first multicellular organism, right? So there's all these individual organisms that have the same genetic code and came from the same, quote, parent or whatever you want to call it, who are working together, which is pretty fascinating. Where this gets particularly interesting is that this paper that I was reporting on from the University of Oregon was co-authored by some people from the Department of Aerospace Engineering and the Autonomous Systems Program of Technion and the Israeli Institute of Technology. So all these people were working together, not only to understand how the salps and the siphonophores were moving, but to see how that could be applied to propulsion systems. Yeah. And what's more, this explains how these salps do an amazing thing every day. They go up to 1,000 meters. That's over 3,000 feet. They go down during the day and they go all the way back up at night. So they call this the greatest migration, right? Because it's this huge amount of space every single day that huge amounts of animals do as part of their daily movements. And these guys do that by their jet propulsion.
Which they could not probably do if they were just individuals, but it's the fact that they're an uncoordinated colony that allows them to do it.
Coordinated swimming machine.
Yeah.
Yes, and the main researcher says, we haven't really moved beyond the propeller when it comes to underwater vehicles. Multi-jet vehicles present a highly effective means of transport and also allow for swarm-like behavior where individual units could break apart from the colony to carry out different objectives.
Well, now I'm afraid of robots underwater, but yeah, I see where you're going with that.
Yes, afraid and excited as per usual, right?
Exactly. As per usual.
As per usual.
But what else are we afraid and excited about?
Are you talking about the eclipse?
Yes.
It's gonna be dark on Monday for a while. Yeah.
At least a couple of minutes for many people across the United States.
Yes, I'm very excited to see it. I've never seen it before. Who knows how I will react? Well, a recent study, actually a recent group of researchers are getting together to try to get data about how animals react during an eclipse. This is all spurred by looking back at previous studies. There aren't a lot of them. The most related study they could find was a study that was published in 1998 from the Journal of Fish Biology. All the way back in 98, they were looking at fish responding to changes in light during an eclipse, and they found that reef fish during a total eclipse, this is in the Galapagos, the daytime fish, the fish that are out when it's light out, sought shelter during the eclipse, during totality.
It's nighttime. This is a weird time for nighttime.
Oh, snap.
But it's nighttime.
Get in the coral. Get in the coral. And then the nocturnal reef animals came right out during totality. Another study from Veracruz, Mexico found that orb weaver spiders, they start to dismantle their webs during totality and then rebuild them when the sun's face is revealed. So I looked into this a little bit. For all I've talked about orb weaver spiders, I did not know this. Many orb weaver spiders build a new web every single day. Yeah, I had no idea. Most orb weavers, they are active during evening hours. They hide for most of the day. Towards the evening, they eat their old web. They rest for about an hour, and then they spin a brand new web in the same location.
Yep.
So this guarantees them that their web is free of detritus.
It's
Keep it
housekeeping.
clean. Keep
the
it
best.
clean.
It's
Yeah.
the best kind of housekeeping. You just destroy your house and
just
eat it.
Yeah.
Eat it all.
Yeah. Bring in the wrecking ball. Let's start over.
I'm gonna start
So-
eating my house.
In
now.
Veracruz, Mexico, during an eclipse, the orbiver spiders started eating up their webs during totality. And then when the sun came back, they started building it again. Like, oh, shoot, wrong timing. So,
False alarm.
yeah. So this brings us to our eclipse happening on Monday. Jonathan Fram, assistant professor at Oregon State University, wants to do a series of bioacoustic sonars to see where zooplankton go during totality. This is part of that greatest migration I was just talking about. They want to see if the zooplankton turn around during the totality. And other scientists want to see what kind of the larger vertebrates are up to. And we don't have a lot of data on this. So some of the biologists at the California Academy of Sciences are actually directing people to iNaturalist, which is this really cool citizen science app that I've certainly used before. A lot of people use now, and they want people to participate if they are within 75% or more of the totality mark. So that's a lot of people, 75%. So 75, 80, 90%, anywhere in there, they want you to participate, all the way up to 100. And then the best part is they want you to actually enjoy the 2 minutes of totality. So they want an observation about 30 minutes before the point of maximum eclipse, and the second either 5 minutes before or 5 minutes after. So again, they want you to experience the totality, but if you're near some animals, they want to know about it. Any animal behavior, they say look for squirrels, look to see if nocturnal animals like bats or owls begin to come out. They also say that they even want information on domesticated animals, dogs, farm animals, to see if it changes their behavior. Some anecdotal information that we have from some of these researchers that are working together to try to get this information. One of the researchers from the California Academy recalled during 2012 seeing all of the birds, or hearing all of the birds, suddenly go quiet, which is very interesting.
Which would make sense when you want to have a bird calm, you put them in a dark place.
Right.
They
Doug
go to-
Duncan from the University of Colorado had a particularly interesting run-in with some llamas. Some llamas gathered together to see a total eclipse with him and his fellow astronomers in Bolivia. When he was in another one near the Galapagos, he saw whales and dolphins swim to the surface of the ocean 5 minutes before the eclipse began, hung out there till 5 minutes after the eclipse, then went back down.
Wow. I wonder what internet they were looking at to coordinate it.
Right. Yes. So the idea here is that most likely an eclipse overrides normal circadian rhythm, which I personally would not have expected. I would have expected it's short enough that the daily rhythm is so ingrained that it wouldn't actually change very much at all. But it's sounding more and more like it's likely to change a lot of behavior. Another anecdotal piece of evidence from a professor at University of Toledo who was in Venezuela during 2008 said that brown pelicans and frigate birds that had been foraging before the eclipse left the bay they were foraging in 13 minutes before totality, and then didn't return until 12 minutes after the solar disk was fully revealed.
And that sounds about right also, because that would be a situation where that's like dusk, where the amount of light that you're receiving at that time point is probably very similar to what triggers them to go to roost. Time to leave, time to stop foraging, go roost, find a safe place.
Yeah.
And then it's dark for only a couple of minutes. And then they're like, oh, it's dawn. Time to get up and go back.
Yeah, but
Time to
it's
go
hard for me
catch
to
the
believe-
fishies.
It's hard for you to believe that the animals don't know that a full day hasn't passed,
But
which is where that circadian rhythm comes from, right?
I think what it does is that it's light triggering behaviors.
Right.
But
So it's
this is-
more of an
this is
instinctual response of
Yes,
darkness means go find shelter.
Yes, and the light, the sun coming back
Mhm.
is dawn, and so go back to your foraging grounds. Go find something to eat. Go back to your normal operating procedures. Yeah.
Yeah. But so if you're anywhere where you can enjoy the eclipse this Monday and you happen to be near a dog or a cat or some farm animals or some birds or, you know, heaven forbid a squirrel, go ahead and take notice. See what happens. And if you want to log into iNaturalist, or you can just do a quick Google search for different places you can record eclipse information. If animals aren't your thing, there are other citizen science opportunities just for recording what the eclipse looks like. You can put the proper filter on your phone. You can put some eclipse glasses on your phone. You can actually send some pictures into a database to help people record this eclipse. So the eclipse coming up on Monday will be a really great time to help participate in science and learn something about what this eclipse means. But I did think it was very interesting to hear how many scientists are very excited to see what will happen on Monday.
Yeah, that I think it is very interesting to discover, because we don't have that many opportunities to really see what happens and to really coordinate an effort.
Yeah.
So I wish these scientists all the best.
Absolutely.
So iNaturalist, that's where you go. iNaturalist. If you want to get involved.
Absolutely.
Cool. Well, maybe Blair and I are going to be hanging out together for the eclipse in Central Oregon. So hopefully, if we can get clear skies, if the fog clears, if the smoke clears from all the fires in Oregon, maybe we'll be able to see the sun and also take some observations.
Yes.
Oh, maybe we'll also be able to shoot a video.
One
Ooh.
recommendation for anybody who's thinking of going, go really early. Don't wait for that day. I'm predicting like end of the world type traffic.
You're probably right.
Yeah, I'm predicting like it's just gas stations running out of gasoline because people keep filling up and heading towards the place where the thing's gonna happen. And then they can't get there because the freeways, it'll look like Mad Max, probably. It'd be insane.
Yeah.
All right, I think we did it. Is that the first half of the show?
Yeah, I was just very overwhelmed by the idea of running out of gas an hour from Portland.
Oh, no.
Yeah. It'll be okay. We're going to be all right, everybody. The eclipse, it is not the end of the world. It's not Armageddon. It's just an eclipse. And if you're in the path of totality, really enjoy it. Take a moment. Everyone, other things to say, if they have not been said enough already, everyone make sure you've got your eclipse glasses. Yes. If you do not have eclipse glasses, properly certified eclipse glasses, because there are a lot of fake ones that are going out through Amazon. So they even have the proper ISO number. So you really want to make sure you have the correct glasses. There is a list of about 17 manufacturers and dealers that are around. I don't know how many they have left. There's probably not time. Maybe there's time for you to do a rush order. I don't know, but make sure that they are good glasses so you don't hurt your eyes. But if you're in the path of totality, you can take off your glasses when totality hits, because the moon is going to be blocking the sun and you will be able to see all sorts of wonderful things. If you have binoculars, you can look at the sun with your binoculars during totality to look for coronal projections and tendrils coming off of the sun from around the moon. If you're wearing your glasses, the solar eclipse glasses leading right up until the totality at the very end there, you might be able to see the bursts of light and shadow through the canyons on the moon, which is something that I'm looking forward to looking for. That's going to be cool. If you do not have glasses, you can always make a pinhole camera and watch the progression of the shadow of the moon or of the moon across the sun. And additionally, or the shadow of the moon across the earth, actually. And additionally, there are some really neat things you can do with trees. Look between, if you're in a treed area, you can look where the gaps between the leaves are, and you'll see many suns being eclipsed on the ground at your feet.
That's my favorite.
Yeah, or a colander. You can use a colander.
You can use a
Yeah, that
colander.
would probably work fantastic too.
Yeah, there are all sorts of tricks if you are not in the path of totality, or if you're at the leading up to or going away from totality. There are many, many tricks. Search for them on the internet. There are some fun ones that you can, if you've got kids that you're going to be looking at the eclipse with, there are some very fun techniques for putting faces, making happy faces, and doing all sorts of artwork with your pinhole cameras and stuff. Yes, and Bleak in the chat room says you can poke a hole in a piece of paper with a pencil.
Yep. That's
There you
also
go.
true.
That is the ultimate in pinhole cameras right there.
Yeah.
So everyone, I hope you are all safe out there for the eclipse. We still have another half of the show left.
Yes.
So this is not the end, my beautiful friends. We're going to take a break, though. We'll be back in just a few moments with more This Week in Science. We got more science news coming your way.
Explain the things you heard with more than intuition. The line of reason shows the way to go. No conclusion. The methods of hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see.
Hey, everyone. Thank you so much for listening to or for watching This Week in Science. We appreciate the fact that you join us week after week for so much fun science conversation and discussion. There's a lot out there to learn about in this world, and we enjoy learning it with you. Thank you so much. For those of you who are interested in helping produce the show and make sure we keep going week after week, there are many ways that you can do that. Little things you can do to help us out. First, if you're interested in merchandise from TWIS, you can head over to twis.org. Twis.org is the portal for all things TWIS. If you head over there, and in the main header bar, you can find a link to our Zazzle store link. Click on that Zazzle store link, and it'll take you right over to zazzle.com/thisweekinscience, where we have many items: t-shirts, tote bags, stamps with the TWIS logo emblazoned all over them. Additionally, we have fun items like tortoise coasters. I was going to say tote pads, but that doesn't work at all. Lots of things: mouse pads, lumbar pillows, mugs with Blair's Animal Corner art from the calendars that she's been producing for us for the last couple of years. Her original artwork to help you, that it's very beautiful stuff that'll help you think about TWIS and also will make your house pretty, right? And a portion of the proceeds goes to TWIS. It supports us in all the things we do. So you can enjoy us, enjoy a little bit of stuff from us, and also help us out. Right now, it looks as though there is a discount code, 20% off with the code Zazzle20. So if you head on over there, you can do that. If you don't need any more stuff, but still want to help us out and help us financially support this show, head to twis.org again, and you can click. There are two options. You can click on the donate button that's down on the sidebar. Click on that. It'll take you through a PayPal donation page, which will give you all sorts of ways to donate to your heart's content, or really just whatever way you'd like to donate. It allows you to do that. However much you want to give, you can just do that. Or you can click on the Patreon link, and the Patreon link will take you to patreon.com/thisweekinscience, where we have our Patreon community, where you can pledge as little as 50 cents, as little as a penny, or you can pledge at the various levels. You can pledge as much as $100 an episode or more if you really wanted to. There are many levels of support in each one. There are neat gifts from us to you for helping us out, our little way of saying thank you for being a part of our community. Additionally, we post on Patreon every week And I write letters to the Patreon community, and Patreon community does get some early content sometimes. And I'm thinking about putting out a very special Patreon-only post-show podcast. I don't know. I've got all sorts of ideas, but the Patreon community is growing, and it's a great place to really dig into the TWIS community over there at Patreon. That said, if you are just want to support us, love listening to us, love watching the show, but really you don't really know what to do, you don't want to give us money, you don't want to buy something, you're like, why is everything so capitalist? Just tell your friends about us. Tell your friends that you found this podcast, This Week in Science, TWIS, and it's amazing. Tell your friends that. Tell your coworkers. Put up a poster. Do something on social media. I don't know, do a dance on Snapchat that interprets your love for TWIS. I don't do Snapchat, but I'd really like to see it if you did that. How about this Monday for the eclipse? Everyone take a picture of yourselves wherever you are watching the eclipse and tag TWIS. That would be pretty cool. I'd love to see that on Instagram, on Facebook, on Twitter. Take a picture, tag us. Let us know what you're doing on Eclipse Day on Monday. I would love that. But anyway, whatever way you support TWIS, we are just glad you are here. We really could not do this without you. Thank you for your support.
Laid down in black ink, never even bothering to stop and think. The only real power that I do believe is the dollars and cents all these authors receive. If miracle wonders were held in their looks, why waste precious time and try selling them?
And we're back with more This Week in Science.
Yes, we are. Hey, Justin, do you have a story for us?
Sure do. T cells in the immune system are a lot like James Bond in that they are licensed to kill.
I was going to ask if they liked martinis, shaken and not stirred.
That too, oddly enough. They are cytotoxic, which means that they can kill cells within the human body. Unlike 007, these T cells don't always win the fight, which is how we get infections and cancers of all sorts. An important reason why that fight isn't always successful has been discovered by a team of microbiologists at the University of Massachusetts Amherst. A microRNA molecule known as lethal 7 has been found to be regulating the attack function of T cells. This tiny strand of microRNA is only 20 to 30 nucleotides long, yet it has a huge effect. Researchers found that when lethal 7 levels are low or absent, the body's T cells can potentially turn into super killers, which is a good thing since these super killers are targeting bad things like cancer and chronic infections. As Leonid Pobozinski explains, we get cancer because T cells are not always efficient and cancer can overcome them. Our lab looks at the molecular mechanisms that regulate cytotoxic effects of T cells. And finding this mechanism in microRNA, this lab is furthering a kind of newish area of study. Back to Quotey Voice, when microRNAs were discovered over 20 years ago, people thought it was a product of RNA degradation. They were considered used fragments, like dust. They are so tiny, nobody paid attention to them. So normally RNA codes proteins, but microRNA does not. Instead, these tiny microRNA SNPs found in humans and mammals have regulatory activity across the whole genome. This is back to Quotey Voice. The specific microRNA known as lethal 7 is a very ancient RNA that existed in the very first eukaryotes and has been conserved through evolution. Humans and animals have multiple genes that code for it instead of the usual just one gene coding for something. Also, the most important genes are duplicated during evolution, indicating these must be very essential things to be keeping going into the future. Experiments were sparked by the observation that T cells produce a lot of lethal 7 molecules. All of them, as long as no danger is present. But the moment trouble appears, poof, suddenly the lethal 7s are gone. Which then it seems, allow T cells to become functionally cytotoxic and able to clear the pathogens. Popozinski says the microRNAs work as a brake on the cytotoxic T cells when there's no antigen present. So when they are healthy, they rest. Or so when we are healthy, they rest. As soon as they are gone, T cells initiate differentiation into cytotoxic T lymphocytes to kill invaders. T cells inject toxic molecules or granzymes into a cancer or virally infected cell that initiates its
apoptotic apoptosis. Yeah.
Programmed cell death. Just say it that way. In experiments with 3 groups of mice, wild type controls, mice genetically modified to have no lethal 7, and another group engineered to have a superabundance of lethal 7, researchers found that the complete absence of lethal 7 yielded the strongest differentiation of T cells into killer status. If you keep lethal 7, T cells cannot become cytotoxic, even in the presence of a tumor or virus, Popozinski says. If you have none or almost none, function is enhanced. Nobody knew this before. We also figured out that the molecular pathway using transcription factors that regulate the T cell differentiation and confirmed that lethal 7 microRNA is the most critical control. So it's not just that there's a correlation, that this actually is the critical component to this. Researchers now hope that this might lead to the ability to modulate immune responses. And they're testing it on mouse tumor models to try to enhance immune response against tumors using the technique. We'd like to develop a way to suppress or enhance immune response. We might be able to combine this with adaptive immunotherapy to enhance immune functions. So we would use a person's own T cells, treat them in vitro, put them back as super killer T cells to boost their immune response. It's very promising. I feel it's a real possibility to go from this fundamental research and have an immediate application. So they're obviously very excited to be contributing to society in this. But that's I love how just 20 years ago, this is dust. Just used fragments, meaningless stuff, these microRNA. And now could be the discovery of something like this that leads to a wide range of immunotherapy cures.
Yeah, so I guess the trick is really here, like getting the lethal 7 to activate in individuals who have cancer so that it leads to that process where...
Get out of the way,
Yeah, get out of the way. Let's have these T cells go in and kill the cancer. Let's do it. So you get those T cells into killer mode.
Yeah.
So
why
is it? I mean, why is it in people with cancer? I guess the cancer is turning stuff off normally. Is that what's happening?
Well, the way he put it,
shut it down.
The way he put it, it just overcomes sort of the number of T cells with the antigen that are looking for cancer. It's just more aggressive. It's just more. There's more of it. It's more active, and so your T cells do attack cancer, but just not in great enough numbers, right? So his proposal is that, okay, we just take out some of your own T cells and sort of put them into a breeding program where they're not going to have the lethal 7. So the brake is off. They're in super killer mode. They're all amped. They're ready to go in. And you put them back in mass, and they go to work immediately. So it's one of those things with the T cells too, is there's an antigen that's looking for something in each T cell, but it's not that each T cell has all of these antigens that look for everything, which is why we make so many T cells. So they have to go in with the ones that are going to be looking for this as well. So there's a couple steps to it, but yeah, our immune system is sort of like there's T cells that are going around looking for the axe murderer in the room. And there are others that are looking for something else. And if they're the one in the room with the axe murderer, they're not going to notice it.
Yeah,
right?
Exactly. So, I'm just going to walk right by.
Just walk right on by.
I'm not interested in that scary killer clown. Not looking for that mask at all.
No, I'm looking for shoplifters, and apparently he purchased that axe. I can see
I can see that.
So there's a couple layers to that. There's a specific T cell that he would be in the case of a cancer. out and putting back in. But yeah, this is just another wonderful one of those maybe possible cancer cure type things. But I do love the fact that it came from an area that, with all the research that's been done, all the looks that have been done, we can see now a mechanism of control within the immunity system, within T cells themselves, that was previously kind of unknown, unlooked at, and thought to be inconsequential, could be the thing that completely changes how we combat this disease.
Yeah, microRNAs are and this isn't the only lab working on them, they are a very active area of study, and there are hundreds of different microRNAs that potentially control so many different aspects of cell differentiation and of immune system function, exactly like this. So this is exciting. Yeah, we'll see where it goes, if it's applicable to all cancers or only some cancers, or yeah, we'll see. This is a beginning. This is a first step from nothing to a potential cure or treatment. Yeah. And sometimes you're in the forest and you find something, and it's not a you eat it because you're hungry, and that takes you places. What?
What is this thing you found in the forest?
What is this thing? Usually you hear about them growing on cow patties or...
Oh, absolutely. Okay, now I know where you're at.
Psilocybe cyanescens, otherwise known as magic mushrooms. They have been the subject of study for decades, and for about 60 years, we've been really talking about their psychedelic effects. Harvard University psychologist Timothy Leary had did a bunch of mind-altering experiments, which got the scientific community all abuzz, and more than the scientific community, led to a lot of people wanting to try to eat mushrooms. He and Albert Hoffman, who was a chemist. There's a lot of stuff going on in the 60s there related to these mushrooms. Well, research since has shown that there are medicinal uses for psilocybin. Psilocybin could potentially be used to treat anxiety and depression in people with terminal cancer, and also in treating nicotine addiction. However, they're limited by the mushrooms themselves, and being able to get the mushrooms, being able to grow the mushrooms, and having quantities that are able to give a pharmaceutical dose of drug of the psilocybin compound to people. I mean, you're not going to say, oh, take 2 of these small caps and 1 of these big stems and call me in the morning. That leaves a certain amount of slop in the actual treatment of a medical condition, right? And so in order to prescribe psilocybin, researchers need to be able to make it. They need to synthesize it and make it in the lab and have it actually manufactured. And in the first study ever to show it, researchers have sequenced genomes of psilocybin mushroom species, 2 psilocybin mushroom species, to identify the genes responsible for enzymatic production of psilocybin. So fungus, mushrooms are a fungus, we are way behind in our production of compounds, our synthesization, I can't speak the words of compounds from fungal sources. Bacteria, we grow in the lab all the time. We've got a pretty good handle on many species and the compounds that they produce. We get bacteria to produce compounds for us, but the fungi are different. And so it's been very difficult to actually make this happen. Janus Frick, Felix Bley, Dirk Hofmeister from Friedrich Schiller University, Jena, published an Angewandte Chemie International edition just recently on this study. They used bacteria and fungi, engineered bacteria and fungi, to confirm the gene activity that was responsible for this enzymatic production of psilocybin, and to verify the exact order of chemical enzyme steps to go from the beginning to the end of this synthesis. The process includes a new enzyme that we haven't seen before. It decarboxylates tryptophan. And there's an enzyme that adds a hydroxyl group. There's an enzyme that catalyzes phosphorylation, which is adding a phosphate, and an enzyme that mediates sequential amine methylation steps. So they basically created a one-pot reaction. They used 3 of the enzymes to prepare psilocybin from 4-hydroxy-L-tryptophan, and the end product is psilocybin. And so they used genetics to find the genes responsible for the enzymes that create psilocybin in the fungus, and then repeated those steps using bacteria and fungus to verify it, to actually get to a point where they can produce psilocybin in the lab. And so this will basically sets the beginning, sets us up for being able to synthesize psilocybin that can be mass produced for medical uses.
Excellent. I'm all about more medical drugs that come from natural sources.
Right. It's from a natural source, but this understanding the enzymatic process gets around having to farm the fungus or any of those. Yeah, it gets around a whole bunch of that. So it's a fascinating study. And I love the fact that it does potentially lead to, I mean, once we have psilocybin itself completely synthesized and engineered on a regular basis, where's that going to take the chemical use of the molecule? You know, how often and how useful will psychotherapists find it? How useful will doctors use it? How useful will patients find it? We'll see where it goes from there.
But that's the whole goal, right? Is to take away the guesswork and to also take away a lot of artificially created compounds that can mess with the environment, human bodies, all these kinds of things. So this is kind of the perfect thing, is something that has a source in the natural world. When it's digested and then released back into the natural world, it's not likely to make a big impact. It's not likely to make a big impact on the internal systems of your body. And all at the same time, we can regulate the dosage very carefully.
Yeah, and that's the big thing, is the dosage regulation, and
I forget the whole word natural completely. I throw that out of every conversation having to do with any narco product, because there's plenty of narcotics that are really rough longer term that can be all natural. Like, that's not a differentiation.
Well, now you're twisting what I was trying to say. You know what I was trying to say.
I don't know that if I am, so is the listening audience. But I think
okay.
I mean, I think this is something that was one of these drugs like MDMA and LSD that was used successfully early on for therapeutic use, and so effective that the people who were using this clinically thought everybody should do this. They saw such success, they're like, just everybody needs to be doing this. And in the greater society, maybe that's not how you really should do it. So
right, and there are, the psychoactive effects of psilocybin are not to be taken lightly. I mean, the hallucinations that can come from psilocybin can be very intense. So this situation, as Blair said, and what I was trying to say is that the dosage is very important in this particular case. And it may be the kind of situation where very low doses, I mean, people are talking about microdosing acid, microdosing mushrooms. These things can potentially be very helpful for anxiety, depression, whether in a clinical therapy setting, or, is this something that if they figure out exactly how the psilocybin has its effect, could it be watered down a little bit?
Sure.
So
and as a false context, I think that's a great argument, but it's not about dosage. What it is I think it's about context. there's
Well, to
great,
discount that
there's a
entire
great
part of
effect.
it is
There's a great effectiveness in using these chemicals in therapeutic environments, regardless of the dosage. Comparing the dosage to the same dosage that's being used at a rock concert or whatever the kids listen to today, the context of what they're getting at, or the meaning of what they're getting at behind this, I think, ultimately is that if you can use it clinically in certain context, then you can have a great clinical result from it. And the dosage thing, I think, is a side that has nothing really to do with it.
I completely disagree because look at medical marijuana. Part of the problem was that marijuana from a person in the street, one strand is very different from another strand. You don't get all of the information that you need. You get a very different dosage. Once you start to make it medical, you can rate things on a clear rating scale. There are testing processes. You can put things in place to make things more consistent.
It'll still be totally meaningless because with anything psychoactive, people are going to react to it completely differently, and the context, of what how they're experiencing and the situation they're in is going to affect them differently. It's not quite like alcohol, and even alcohol, which can affect some people differently, has a very much how much is in your blood stream to how it affects your way in the world is completely and totally different subject than when you're talking about psychoactives. So.
Yeah, and Ed from Connecticut in the chat room saying taking the drugs in a regulated environment is the key, and that's exactly what these medical uses would be. That's what these therapeutic efforts are for depression, anxiety, PTSD, pain. These are all indications that would be potentially clinical in nature, and so they would be controlled environments for the most part. This is not like here, take your isolated psilocybin pills and go home. Yeah, that sounds like a great idea. That's not going to happen.
And it's also not necessarily has to be a positive environment. One of the most positive usages of LSD was on prisoners who had much lower levels of recidivism than your typical prisoner who was going in and out of the legal system, largely because I'm thinking hyper aware of your surroundings of four walls, a cinder block, and some bars, probably stuck with them a little longer after that experience. But lower levels of recidivism when used in prison, better therapy outcomes when used in a clinical environment. This is definitely something that should be part of the toolbox of medicine.
Absolutely. Yeah. No, and the easier we can make it to be a useful tool, the better. What you got there, Justin? Got a new story?
Oh yeah. My final story of the eve. This is the e-cigarettes. Some bit of truth about them. Dun, dun, dun. Turns out among U.S. adults who were established smokers in the past 5 years, those who use e-cigarettes daily were significantly more likely to have quit cigarettes compared to those who had never tried e-cigarettes but were smokers. Researchers at Columbia University's Mailman School of Public Health and Rutgers School of Public Health found that over half of daily e-cigarette users had quit smoking in the past 5 years.
They quit smoking cigarettes, not smoking e-cigarettes.
Correct. Compared to just 28% of adults who had never tried e-cigarettes. This is one of the first studies to reveal the patterns of cessation prevalence among e-cigarette users at a national level. So, it doesn't say anything to the long-term health effects of vaping or the chemicals within vape, but it does say, in terms of smoking cessation, as the e-cigarettes had sort of purported that they were all about early on, seems to be working.
Okay, now I'm going to pull a Justin and say, but that doesn't really matter because most of those, or I would guess a lot of those cases have to do with this marketing that's indicating e-cigarettes will help you quit smoking, which makes people think that they are making a healthy option.
Right.
They're making a healthy choice. Yeah. And that is good marketing and incorrect.
Well, we know that cigarettes are bad. So, yeah,
We know that e-cigarettes are bad as
We don't
well.
know that they're as bad yet. And that's I
We
guess
know that they are bad.
we don't know that they're as bad. And this is the thing.
Oh
that
boy,
we're-
I don't know if that matters, Justin.
is-
If you're
what is
convincing
bad,
people,
No, I mean seriously, it is. It's not. I mean, you're drawing a line at you're putting something in your body that's bad. You're inhaling something that's bad. You're drawing a line there where we don't know potential risk, and so the for a long time we've known cigarettes increase a lot of risk because of tar, because of other pollutants that they put in into your body. The nicotine is secondary, actually. The nicotine just causes addiction, but it's the smoke itself that causes so many problems. E-cigarettes, we're finding out that the propylene glycol is not so great to be inhaling. Not good, but it doesn't have the same tar and other factors that you're inhaling in the
Right.
smoke. So is it necessarily the risk factors to how bad it is?
Okay.
And so if you're going to make a choice between I'm
Right.
smoking a cigarette every day and I'm smoking something that's potentially less damaging, still damaging, but less damaging, which do you choose?
right? I would say it rings very similar to me to the diet soda debate. And
We're going to talk about that next. So don't
great.
even. We'll get
Oh,
there.
okay, excellent. Let's talk about that.
But a little bit on the side of that, just to finish it up, the FDA has recently delayed rules that they had that would have limited e-cigarette marketing, which may be a good thing. Again, I agree with you, Blair. I agree with you. It's not that you're doing a healthy thing, and I agree with Kiki. It's doing a less healthy thing or less unhealthy thing.
Less
It's, it's still unhealthy, but just slightly less.
Yeah.
But I feel like marketing indicates that it is. See, you quit smoking. You're great.
No, you're
See,
still
you did your
smoking.
job.
If you're smoking an e-cigarette, you're still smoking.
That's what
It's
I'm saying.
just relatively
but the
less
marketing
damaging.
has this indication that, oh, you quit smoking cigarettes. You're now smoking an e-cigarette. You're good to go.
I'm saying run from the devils you know are devils.
Yeah, it's a really interesting. This here, we're still in the world of lobbying money and influence from the smoking industry. So it's hard to know, even though people are doing scientific research on this topic. It's very difficult to separate the cigarettes from the e-cigarettes, the wheat from the chaff in this particular case, because there is a smokescreen being laid to confuse people, and lobbying money, literally, and lobbying money is being used to try and keep e-cigarettes from the market, or at least from making up as much of the market, because cigarette manufacturers are losing money. So there are lots of pieces in play here, but it's nice to see a good study come out in a journal like Addictive Behavior. So more like this, please, so that we can make policy decisions based on lots of scientific evidence. Yes. And then thinking of not policy decisions, but maybe decisions about what you drink or eat every single day. Do either of you guys imbibe diet sodas?
Nope, I don't drink soda.
I don't even drink the well, occasionally, but very rarely do I have a even non-diet soda.
Yeah, on occasion. Usually when I'm on a road trip. I don't know why.
Exactly what I would say. If I'm driving the kids anywhere that's going to be more than an hour, I got a soda in there. Absolutely.
Need the caffeine.
That's
my
right.
cup of coffee, because you can put a top on the thing, versus a regular cup of coffee, it'll just be spilling around.
Yeah.
Right. Or you've gotten in it, there's a straw, and it makes it super easy to be able to drink. Yeah, anyway. Well, a lot of people drink lots of diet soda. A lot of people drink regular soda, less and less, actually. But there's been a big question since the war on sugar began. There's been a huge effort to get people off of full sugar sodas and drinking diet sodas. But in the process of moving people from sugar to artificially sweetened beverages, we found that the evidence is very confusing. And while people do lose weight to begin with, there's weight loss when you move from taking all those calories in from sugar to not having the sugar-related calories from your beverage of choice. A lot of people still run the risk of obesity, diabetes, and metabolic disease who drink artificially sweetened beverages. And so the question is, what's going on? How come if you're drinking, why, if you're drinking these artificially sweetened beverages, are you still potentially not losing weight? Why is your body storing fat? What's going on? And so a researcher, Dana Small at Yale University, she's a neuroscientist, she just published a big compendium of some studies that she's done over the last few years in current biology. And she's been studying what's going on in the brain and in the body in response to these sweeteners. And so one of her studies, the main way that she varied the factors is that she had sweetness, which could be controlled by an artificial sweetener, right? You can make different drinks equally sweet. And then she also has a tasteless carbohydrate, maltodextrin, that she could mix in. And so she basically controlled a bunch of beverages. She had all of them the same sweetness. So sweetness wasn't the issue, but they had different amounts of calories: 0, 37.5, 75, 112.5, and 150 calories. The subjects consumed each drink 6 times over a period of weeks. They had it twice in the laboratory, 4 times at home, and then their brains were scanned using fMRI to see what happened in the reward circuits in the brain. And so she was predicting, what would you predict? If you have these same sweetness, but different amounts of calories, what's going to happen in the reward circuit of the brain?
Less calories made them want more.
Oh, interesting. Okay.
Yeah. Okay. Wait a sec. Wait, I think I know the answer to this. So I think it's the sweetness makes you think you've taken on more calories than you. No, I give up.
But they're all the same sweetness. So she predicted that the more calories were in the drink, the greater the activation of the reward circuit in the brain.
Mm-hmm. Yeah, exactly. So less calories would make you want to consume more, right?
But that's not what she found. She found the one in the middle, the 75-calorie drink, not the 0-calorie drink, not the 150-calorie drink, but the one right in the middle generated the strongest activation of the reward circuit. And so she was asking, okay, if calories are what is appealing about sweet foods, why would the 75-calorie drink be more activating than the 150-calorie drink? Why would that happen? And so she did more experiments, and she looked at the metabolic response. And that's how the body revs itself up to burn calories, basically the energy that's expended to process the calories that you take in. Excuse me. And again, the same drinks, 0, 75, 150, same sweetness to all of the different calorie variations. She found the results repeated again. The metabolic response to the high-calorie drink and the 0-calorie drink was lower than for the middle one. And so what she thinks is that sweetness regulates the metabolic signal. So when sweetness and calories are matched, where they kind of fit together, the amount of sweetness fits the amount of calories that you're taking in, expectations are matched. The brain's expectations are matched. And so you have the greatest metabolic response and the greatest brain response as well, because you have a matching of calories to taste. If there's a mismatch, so it's super sweet and no calories, the system's like, this is weird. I don't know what to do. And so the metabolism doesn't rev up. And because the expectation mismatch occurs, the brain and the body, the brain's like, well, the sweetness wants me to rev up, but no, there's no calories here. Or if it's not quite sweet enough and there's lots of calories, the same kind of thing. Well, why should I do that? And so instead, for this high sweetness and no calories, you potentially have the body storing fat if you are taking in any other calories at the same time. And so she's saying what she suggests is this very complex thing, but it might indicate that you shouldn't drink artificially sweetened beverages while you're eating.
Oh.
Because it creates that mismatch that the body can't really deal with. And so you may end up just storing calories as fat as opposed to trying to burn through them. The metabolism doesn't rev up, doesn't do what it's supposed to. It's still very complicated, still not quite. I mean, this is a big study, and there are a lot of questions still to be answered. But there is this, our love of sweet foods and how that drives our reward center, our brain body systems, our metabolism. And she says taste can change the metabolic fate of calories. And the idea that in this article from Vox, I really love the last sentence. Mark Schatzker is the author of The Dorito Effect, The Surprising New Truth About Food and Flavor. He writes, in other words, the take-home message here, the dream of foods that taste great but have none of the calories may be just a dream.
There we go.
Yeah, it just messes up your body. Your body goes, what? I don't know what to do. Yeah, so anyway, I don't know. If we're doing a road trip, drink your artificially sweetened beverage and don't eat any Doritos.
Oh, no, that's not possible. That's a good chip.
Do you guys have any more stories?
I have a silly story about jumping spiders.
Yeah.
Our dancing, tiny, little, adorable friends. Well, I have a story about the regal jumping spider, the largest of the jumping spiders at 1 inch long. There have been several accounts, so many, a total of 6, of them eating frogs and lizards. This is very weird.
Yeah.
This is not yet been documented. Usually frogs or lizards will eat jumping spiders, but there are accounts and pictures, 6 total. Whopping 6 sample size.
We're sure they're not photoshopped.
Right. Showing the 1 inch spiders dining on Cuban frogs that were 1.5 times their size, and lizards like anoles that were 1.5 to 2.5 times their own size. They don't engage with battles in their prey. They actually inject them with venom and then just wait for them to die. And this was the first ever documented case of jumping spiders killing and eating vertebrates of any kind. This is coming out of Florida.
I'd love to know if, because they're injecting venom, and venom probably is costly, I'd love to know if they vary the amount of venom they inject based on size of prey.
Yeah, I would bet. That's pretty standard when it comes to venomous animals. I actually wanted to show you the picture really quick before we move on of a jumping spider.
I can do that.
Eating a frog. Look at it.
Yeah, there we go.
Ah, look at the look on that frog's face.
Oh, Kermit, you never knew that spider was going to come get you, did you?
And look at that adorable jumping spider doing that terrifying thing. Jumping spider, why don't you just go back to dancing? Go back. Leave that frog alone.
Yes. Oh,
And if anyone would like to see that picture, go ahead to twist.org and look at our show notes.
Tomorrow, after I've had a chance to put them up.
Tomorrow.
Yeah, after this shit goes up.
Tomorrow.
Yeah, after it's up. So I have another spider-ish story I can move to. Very quick headlines at the end of the show. Researchers, this story, I love this story so much because it brings together spider silk, lasers, and Kevlar. Yeah. So researchers have been shooting lasers at spider silk, and they've found that in the right conditions, there's a physics effect that takes place where there are nonlinear multi-photon interactions. Basically, what happens when they shoot photons through the laser at the spider silk, in the spider silk in a particular way, it amplifies the laser's power by basically combining photons together so that two photons act as a single photon, but of twice the energy. So it's this combinatory effect. The spider silk can increase the power of the laser in that way.
Spider silk laser gun. Awesome.
That's right. And so the researchers have been able to direct energy because the spider silk then absorbs the energy of these photons, and they've been using it to make art and sculpt with spider silk. And so the researchers have since been able to focus this laser on different areas of the spider silk to form it into curlicues and to braid it and to cut it into pieces and bond it with other things. And yes, weld with spider silk. They used the laser and spider silk to weld spider silk to the four corners of a mirror and then suspend the spider silk like cables from another structure to suspend the mirror in place. So this little tiny mirror was suspended in thin air by spider silk. Yeah. And then they used it not only to do that, but to weld it to Kevlar. And so the interesting, exciting thing here is that in being able to add spider silk to the Kevlar, that this is something potential for increasing the strength of the Kevlar material, because we all know that spider silk is very strong.
Wow.
Yeah. So they're welding ish with lasers and spider silk. It's pretty fun.
There was another story this week that I'll just tease so people can look it up later about how spider silk is organized. The fibers in spider silk are organized in such a way that when the spiders dangle on a singular piece, they don't twirl around and around and around and around and around. It allows them to stay stationary facing one direction. It's pretty fascinating. Yeah.
Is that
I've
really
always
a thing?
wondered about that.
That's really a thing?
Yeah, you don't want to just spin.
Yeah.
And you don't want to have to spend your energy not spinning. Oh, that's fascinating. New research has shown proof of a concept that antibiotic-carrying molecular robots can treat bacterial stomach infections. These researchers created a micromotor drug delivery system that is powered by bubbles. That when the micromotors, they're magnesium-based micromotors, and when they are put into the stomach, they propel themselves through the gastric fluid because of the production of a carbon dioxide gas that then shoots out of one side of the material. So they have magnesium beads that are covered in titanium dioxide, and then the drug PLGA is put over that, and then they're all covered up with this chitosan material, and then they can be just swallowed. And they tested this in mice, and they were able to treat a Helicobacter pylori infection, which is one of the causes of what's the thing in the stomach? Anyway, it's one
Food
of the
poisoning.
No, not food poisoning.
IBS?
Oh, never mind. I'll just stop right there. But Helicobacter pylori, and it worked pretty well. And usually they have to add, when you're taking a stomach antibiotic, they add a proton pump inhibitor. And when you add the proton pump inhibitor, it works about the same as this molecular motor, this little tiny robot that propels itself with bubbles through your gastric fluid to the infection. But proton pump inhibitors can have all sorts of secondary effects that aren't great. And so you don't feel very good when you're taking them. So this could potentially be a really nice way to address bacterial stomach infections with robots in your stomach. Robots
Sign me up.
propelling themselves with tiny bubbles. And then finally, a study this week has found, by looking at the National Cancer Database, researchers from Yale found that people who choose alternative treatments to conventional medical treatment are 5 times as likely of dying within 5 years as people who just use conventional medical treatment. Yeah, so they reported in the Journal of the National Cancer Institute. There are a few caveats to this, of course. They had a very limited database because not everybody says, "Hey, doc, I'm gonna go take alternative treatments." Some people never said that. There were no records, or there are limited records from the conventional doctors putting them into the database. So there were lots of gaps. They only had about 280 records of patients who chose alternative medicine over conventional. And they tended to be female, young, with high education and income, and didn't have very many other complicating health conditions. Those individuals from the study, the 280 of them, were matched with 2 other patients who were diagnosed with cancer in the same year, had matching age, race, disease stage, and insurance type, but who opted for conventional treatments. And then they were followed through the data over time. And they found that those in the alternative treatment group were 2.5 times more likely to die within 5 years of treatment than the conventional group. It's dragged down by cases of prostate cancer, which tend to progress slowly. And so there's no statistically significant difference in mortality risk among prostate cancer patients, regardless of what kind of treatments they chose. And this is according to Ars Technica. Patients with breast cancer, however, alternative medicine users were 5.7 times more likely to die within 5 years. Colorectal cancer, 4.6 times more likely to die with alternative medicine. And lung cancer were 2.2 times more likely to die if they chose alternative over conventional methods. So there's no actual determination if the alternative therapies are the cause of the drop in survival rate versus lack of evidence-based conventional ones. This is observational. They're just looking at data. It's not actually testing to find out what works and what doesn't work. But this is something that should raise red flags for people. At least give people pause, potentially.
Mm-hmm.
Mm-hmm.
The beauty of standard medicine is that it goes through scientific rigors, and hopefully it means that there are a lot of tested, well-researched methodologies involved.
Right. And the downside of it is, of course, not everybody has access to it.
Right.
And
Absolutely.
That's, if nothing else, that this is something that this should point to. It's not just that trying the alternative for a lot of people is an option because they heard something, read something, don't trust their doctor. But for anybody without access to healthcare for these things, the results are also there in that camp.
Yeah, absolutely.
Yeah. And another thing that this study does highlight is the fact that the data is not strong. The fact that they were not able to find many patients between 2004 and 2013. That's a wide range of years, and they should have been able to find many more individuals in the records, and they were not able to. So there's a breakdown somewhere between alternative medicine treatment clinics where people may be going for treatment, people who choose to leave conventional medicine. If we want to do another study of this type, there is no way to get that information easily at this point in time to find out. I mean, and maybe there is other data from alternative medical clinics that we don't have because it's not in the National Cancer Database. So,
right. Which
Yes.
raises questions.
Yeah, it does raise. There are questions. Absolutely. We have questions. We always have questions. Do you have questions? I hope we gave you more questions today. Yeah. I always leave the show with more questions than I started with. Really? I didn't even know that was a thing. Now I have to go look some things up. Oh my goodness. Everybody, have we finished the show? We did it.
We did it.
Yeah, we did it. We did it. And I would like to thank everyone for joining us today. I would like to thank our chat room for chatting. I know that a bunch of people just got booted from the chat room. I don't know what happened, you guys.
Yeah, me too. I got booted.
Yeah, there was an IRC issue, but we're back in. But IRC people, thank you for sticking with us through the show and chatting through the whole thing. It's great to see your comments there. And Fata and Brandon and Identity 4, thank you for all of your help on a weekly basis and making this show happen. Hey, you guys on Facebook. Hey, everyone on YouTube. Thank you so much for watching us over there. And I would like to take a moment to thank our Patreon sponsors. Thank you to Paul Disney, G. Burton, Lattimore, John Ratmaswamy, Richard Onemus, Byron Lee, E.O., Kevin Parachan, Jacqueline Boyster, Tyron Fong, Andrew Groh, Keith Corsell, Jake Jones, Gerald Sorrells, Chris Clark, Richard Hendricks, Charlene Henry, Brian Hedrick, John Ridley, Steve Bickle, Kevin Railsback, Ulysses Adkins, David Friedel, James Rattle, Bug Caller, Mark Mazzaros, Edward Dyer, Turner 84, Layla Marshall Clark, Larry Garcia, Randy Mizuka, Tony Steele, Jaron Yago, Steve DeBell, Louis Smith, The Harden Family, IFSHMN, Greg Guthman, Patrick Cohn, Ksenia Volkova, Daryl Harun, Sarang, Alex Wilson, Jason Scheiderman, Dave Neighbor, Jason Dozier, Matthew Litwin, Eric Knapp, Jason Roberts, Richard Porter, Rodney, David Wiley, Robert Aston, Sir Frankendelic, Rister Rappin, Dana Pearsons, Paul Statton, David, Brendan Minish, Dale Bryant, Todd Northcutt, Arlene Moss, Bill Kersey, Ben Rosick, Darwin Hannon, Grady Garcia, Felix Alvarez, Brian Hone, Orly Radio, Brian Condon, Mark, Nathan Greco, Hexator, Mitch Neves, Flying Out, John Crocker, Christopher Dreyer, Artyom Chiwata, Dave Wilkinson, Steve Mashinsky, Rick Remus, Gary Swinsberg, Phil Nadeau, Braxton Howard, Salgood, Sam Metzetter, Emma Grenier, Philip Shane, James Dobson, Kurt Larson, Stefan Dimsum, Honey Moss, Mountain Sauce, Jim DePoe, Jason Olds, James, Paul West, Alec Doty, Illuminamo, Joe Wheeler, Dougal Campbell, Craig Porter, Adam Nishkan, Aaron Luthen, Marjorie, David Simmerly, Tyler Harrison, and Columbo Ahmed. Was that faster?
Yes.
Was that faster?
Yeah.
That seemed pretty fast. I messed up a few times. I tripped over my tongue a few times.
Micro machines.
Everyone, thank you for your support on Patreon. If you're interested in finding out more information, you can go to patreon.com/thisweekinscience. Remember that you can also help us out simply by telling your friends about TWIS. And on next week's show, we are excited to be interviewing the authors of The Expanse. Mr. Abraham and Frank will be joining us, otherwise known as James S.A. Corey, will be joining us for a conversation about the science of the Expanse universe. And as far as I know, they are finishing up book number 7 right now, which gives me hope for a very long run of the Expanse on sci-fi. It's very exciting. You guys, I'm so excited about next week's show. Homework, everyone. If you have not looked into the Expanse, you might want to, so you know what we're going to be talking about, right? Once again, we will be here broadcasting live online at 8 p.m. Pacific time on twis.org/live. You can watch and join our chat room, but don't worry if you can't make it. You can find past episodes at twis.org/YouTube, facebook.com/thisweekinscience, or twis.org.
Thank you for enjoying the show. TWIS is also available as a podcast. Just Google This Week in Science in your iTunes directory. Or if you have a mobile type device, you can simply look up TWIS #4 Droid app in the Android marketplace or This Week in Science and anything Apple Marketplace-y.
For more information on anything you may have heard here today, show notes will be available on our website. That's at www.twist.org, where you can also make comments and start conversations with the hosts and other listeners, watch terrifying pictures of spiders eating frogs, etc.
Or you can contact us directly. Email Kirsten at thisweekinscience.com, Justin at twisminion@gmail.com, or Blair at blairbaz@twist.org. Just be sure to put TWIS, TWIS, somewhere in your subject line, or your email will be spam filtered into oblivion. You can also hit us up on the Twitter, where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We will be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
It's all in your head.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. This week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just better understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. Jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say. And if you learned anything from the words that we said, then please just remember it's all in your head. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.
Boom. Should I put more of these guys in my hair?
The gaggle of scientists up there.
Oh, eclipse costumes. I don't have an eclipse costume.
Yeah, I don't have an eclipse costume.
This is now my science headphones. They've always been my science headphones. Powered by magnets. Look at that. It's like a...
It's a science tiara.
Here's my tiara. I feel like a pretty, pretty science princess.
Yay!
Hi. Now the show's over. I can keep drinking my wine. Nice. Post show, everybody. This is the time when it's after the show. It's the after show, the post show, the don't you know show.
I don't know how long I'm gonna last.
No, it's okay. We don't have to last very long. Oh, wait. But
I have to finish packing.
told people, wait. Oh, yeah, you're packing, huh?
Because I have to work tomorrow and we're leaving straight after work.
What?
I think, I don't know for sure yet, but I think I might be riding in a Tesla.
You haven't figured that out yet?
No.
We should, because won't that affect...
No, we have a backup plan.
Backup plans.
Yeah.
I need to send a message to... I'm going to invite some patrons to hang out with us for a couple of minutes.
While you're doing that, I will be right back.
Oh, okay. I'm done now.
Sorry. Oh, okay.
Sorry. No, you can
It's
go. What
2
you gonna
minutes.
Go do?
Okay. Hold on.
Thanks, Identity 4. This is my science tiara. Got some too many tags, though. I need to fix that. This is an impromptu science tiara. The tags. Here, hello, upside down science head. So many tags here. I can just wear them right there, right on just the front, right there. Who needs eyes anyway when you've got science to lead you? It's my now it's my science visor.
Rob the Sparky, put a solar panel on the roof of the Tesla.
Yes.
Did I say this already? I don't think I mentioned this before. I went to did I talk about the Tesla batteries?
What about the Tesla batteries?
So they have this at-home usage. I'm sure I talked about this last time. They have this at-home.
Oh yeah,
usage.
the batteries. Yeah. They've
Yeah.
yes, the wall battery, the batteries they're making.
Yeah. So they're Mishka's is experimenting with this.
Oh, cool. Mishka's, for those who do not know, is a great coffee shop that's been around in Davis for many years. They make their own coffee, roast it right there.
Yeah, there's an experiment underway by Mishka. I don't know what
Sanisha?
Sanisha, sorry, thank you. Sanisha is.
I can't believe I still remember his name after
Yeah,
all these years.
He recognized me, but he couldn't remember how. And then I forgot. I went to the old Mishka's, not the new one so much, but the
Oh, is
old
there a
one.
new one?
There's been a new location now for years.
Oh, I don't know that at all.
Yeah, but I think he might have known you, and that's how he
Mhm.
came to know who I was. But anyway, he was telling me about that they're experimenting with the idea. They've got some sort of test underway to see how it works, but of drawing down electricity in the non-peak hours overnight, and then re-releasing them during the day. And the expectation on his calculations, at least, is that this might actually be more effective than the solar panels on the roof, because the roof space is limited. But this could be a way of utilizing energy that would otherwise possibly just be going to waste, I guess.
Yeah. Hey, Strengths. Yes, the power wall. Thank you for that.
Power wall.
Wait, so what are they using? What
He has strengths, and he might have thought I was Jeff Goldblum.
That's right, totally. So normally you use the solar panels with the power wall. That's the way, like Tesla's setting it up so you can have solar panels, or you'd have the solar panel.
So this is a sort of innovation on that, which is that you just use the power wall to draw down off-peak hours. So it's still coming directly from the grid.
Oh, but it's off-peak.
It's off-peak. It's in the middle of the night. It's 2 a.m. to 4 a.m. or whatever.
Right.
So
it's basically, it could potentially help to distribute electricity use more evenly.
Yeah. And so you're buying it low and you're using it when costs would be high, which means you're making
sell high.
Which you're making less of an impact when there's the heavy draw. So you're making that a little easier and a little perhaps cheaper. And then you're utilizing that energy that I guess kind of just is out on the grid and could, not be being used. And that's why it's the off-peak hours. They need to get it out there. So interesting concept. I think that has huge potential.
Super potential.
Mm-hmm.
Yeah, that's actually interesting. Yeah, I hadn't thought about that. But if you could add it also, I mean, the power wall is limited. You get a couple of power walls and get electricity off peak, get solar panels that bring in solar energy.
Maybe you could get in contact with him during this experiment phase. And if it works, we could talk to him about how it worked in the post-experimental phase.
Right.
Because that'd be a pretty interesting greening.
How'd it go, Sanisha? How'd that all work out?
Yeah.
Yes. Mishka. Iponi in the chat room is saying Mishka means mouse.
Mm-hmm.
Yeah, and hot rod. Yeah, maybe there wouldn't be such thing as off peak anymore, peak or off peak.
Well,
if it became
eventually,
popular,
but that would mean that
Everything would be
if that's the scenario, then all the on peak would have to be cheaper too. So, if you just did that, then you're being successful. So how do you do it?
Who do we have in the chat room? We've got a bunch of people in the chat room. Hello, everybody. Are there some new people in here? Seeing Michael, year 17, about year 17. Yep. For a little while. TWIS.
Oh, wow. Yeah.
Yeah.
TWIS can drive. TWIS can have a driver's license. That's awesome.
That's right. I wonder, let's see. We did a 500 episode anniversary. We passed 600 without much fanfare. And we'll get to 700 in another year and a half-ish. And then no, we'll be at about 800 episodes maybe when we hit 20 years. It's nothing. 20 years, 800 episodes, it's nothing. Strengths. Will the solar eclipse affect the time of TWIS next week? No.
Oh.
Why would it? I mean, unless everything really does go to heck in a handbasket. No, because TWIS is on Wednesday and the eclipse is on Monday. It'll be fine. I am expecting to be back at work on Tuesday. Bleak is out. Don't be bleak. I'm glad we have our chat room back. I told her. Like that. Ben Rothig is here. Little mouses that love cables and batteries. Rah! Yes. Don't eat my cables. My cats want to eat electrical cables. That is not going to end well.
Oh no. That's why rabbits was once a bad experiment.
Yeah, you really like chewing on things.
Rabbits were very attracted to and ate through every power cord in the house. That was left in if you had it high power cord, they're not great climbers. But if it was on the ground, power cord is going down.
Yeah. So Hot Rod says, we all know eclipses cause time warps. And Strength says, I'm expecting a Mad Max Fury Road style apocalypse. Yeah, we would need a lot of chrome paint for that. Exactly. No, it's or is it the solar panels? Block out the sun with panels. We could do that. We could make our own eclipse. Rob Sparkley says, cover the world with solar panels. Too many solar panels, you guys. We could put solar panels in places where there's sun, lots of sun shining down. Yeah, start saving up. Exactly. Yes, and the solar panels will take the sun away, and the trees won't be able to grow because the solar panels, they're like sun magnets. They're just like, nope, I'm going to take the sun, and you're going to be dark over there. That's not how it works. That's not how it works. But if you cover everything in solar panels, let's build up a parking lot. What was that song? Cover the...
Don't know what you're talking
I
about.
have the song in my head, but I can't quite get there. It's right on the tip of
Tear down to something, put up a parking
put up
lot.
a parking lot. Yeah, exactly.
That's all I have from it.
But instead it would be put up solar panels. And so you wouldn't even pave paradise and put up a parking lot. Thank you. I told yes. Yeah, see, you wouldn't even have a parking lot. You just have solar panels. No place to park your car. No trees, no vegetation, no lawns, no swimming pools. It would just be solar panels everywhere. Australia has decided they have put the big go-ahead to the major solar collector solar array. Did you hear about this?
Nope.
They've been solar... it's a solar tower. Yes, solar thermal. South Australia is going to build the world's largest single tower solar thermal power plant. These things are awesome looking. It's like if our civilization were to just disappear and something like this were left behind, future archaeologists would be coming up with all sorts of ideas about it being a shrine or something. Shrine to the sun. Yeah, but it's so South Australia has announced a deal with Tesla to create the largest lithium-ion battery storage facility, and it also has plans to build the biggest single solar tower thermal power plant with proposed output of 150 megawatts.
Nice.
Yeah. These things are so neat. I love this giant tower. And so it's solar thermal. And so there's usually a salt solution or some kind of water salt solution that gets pumped through pipes. And there's a heliospheric array, which keeps the tower constantly illuminated by the sun as long as the sun is out. And the light onto the tower heats usually a salt solution of some kind that can hold the heat for some period of time and then can heat water, run turbines, create energy, all that kind of stuff. I think these things are so neat. Go Australia. You go with your bad selves. It is not the Tower of Mordor.
The Eye of Sauron.
That's right, exactly. Yeah, Identity 4 says for comparison, if you're going to compare megawatt output per size, a typical nuclear reactor in the United States puts out 1,000 megawatts. And so this is only going to be putting out 150 megawatts. And so significantly less power, but also significantly less environmental impact.
Yeah, just some fried lizards from now and again.
Yeah.
That's it.
Just some fried lizards. Not so bad.
Yeah.
And should be completed in 2020. I love it. I think it's great. Let's see. 150. I'm going to look up 150 megawatts powers how many homes? Google, you know what I want to know. Google wants to
Google's
answer
so
my question
smart.
for me. Yeah. Okay, let's see. Mega what? That's pretty funny. With the Boise Weekly says that according to the Solar Energy Industries Association, the number of homes powered by a megawatt of solar energy depends on average sunshine, electricity consumption, temperature, and wind. Nationally, it's 164 homes per megawatt.
Wow.
Yeah. And that is powered by a megawatt of solar photovoltaics. And so that's photovoltaics. Solar thermal maybe could be more. Conventional wisdom says a megawatt can supply 1,000 houses.
What? That's a very
But
different
that's-
number than the
it
164
is. That's from
before the
interesting.
internet was invented.
Well, I think it also, before the internet, 2004. No. I think it's based on average power use and wind power is being produced. So solar photovoltaics don't store energy. And so, yeah, interesting. So it's like a factor of really how quickly can those megawatts be produced and pumped out to the houses.
Mm-hmm.
Indicates how many houses it can actually fuel. Yeah. Nuclear plants are very spendy. Probably a lot more spendy than this solar thermal tower, I would imagine. Yeah, and hot rad it probably doesn't work incredibly well when it's cloudy either, but it's southern Australia, probably in a region that is pretty sunny most of the time. Although it's southern Australia, not northern. Southern's going to be more temperate and less equatorial. What happens to the birds that try to land on the tower? Yeah, incinerated. Exactly. Yes, right. Cover wind turbines with solar panels. And you have solar and wind at the same time. Yeah, and then there's, yes, Rob Sparkley, the idea of the micronuclear plants. All sorts of new ideas. We have lots of new ideas. I'm laughing at something that somebody said in the YouTube chat. That's funny. That's a funny comment. That's a funny comment, Yak Face Club. I love everybody's names. Oh my goodness.
You're a yak face club.
You're a yak
No,
face.
you are. No, you
No,
are. Oh,
you
said it
are.
first. You said it first. You win.
Good. Let the record show.
Let the record show.
Blair
That's
won.
right. Blair always wins.
Yes.
It's just Blairdom.
You know it.
What? All right. Okay, Blair, so you're coming in Friday.
Huh?
Do you know what time?
Probably pretty close to 9.
Okay.
Well, because I'm thinking we're going to Crater Lake in the morning. We're going to try to go early, but it says it takes about 5 hours to hike it all. Which means then we'd be leaving by like 1 or 2, and it's another 5 hours. Plus, we might, if we have an electric car, we might have to stop and charge it. So I think it's going to be
That's
close
another
to 8.
4 hours.
No,
No, it's
we're
20
gonna
minutes.
We're going to use superchargers, so it's going to take, I think it takes 30 to 45 minutes for a full charge.
Which is a nice
At
stop
80%,
for a meal.
80%.
And it's and it's we're getting the long distance one, which means you have a 400-mile
Awesome.
trip on the charge.
Yeah.
If we get it. We'll find out tomorrow.
I can't wait to find out if you get it.
Yeah, which also means
Great.
I'm going to be a passenger in a car that's being used, that autopilot is being used. And I'm going to be freaking out the whole time. So you know how I'm distrustful of self-driving cars.
I'm sure you can choose to drive it. Right?
Yes, you can, but the
No?
expectation if we get this Tesla tomorrow is that we will be testing all the features.
Guinea pigs. Love it. Good luck.
Yeah.
And you can take a video of it.
Oh, I'll take some videos.
Yeah.
For sure. I'll have to see what I'm allowed to post to social media.
Hopefully you can post everything to social media.
I think I should be able to.
I mean, you're a media person now.
Yeah.
Not just a zoo employee. You have a podcast.
Yeah. This is the person who I'm going with, her husband, who's also coming, works for a certain company.
Oh, okay.
And so that's why we
Is
find
it
out.
Tesla?
Yeah.
Uh-huh.
So we'll find out tomorrow if the test car is available.
Cool.
Yeah.
Well, there won't be a lot of trunk space probably.
Well, it has a frunk.
Oh, right.
Mm-hmm.
A frunk.
It says a trunk and a frunk.
You can't, that is not an okay word.
It's the word that Tesla uses.
It's not okay. In
Really?
England, they call it the boot. Just put it in the boot.
No, but the boot's in the back.
No.
Do I need to look up frunk on Urban Dictionary? Is that what you're telling me?
I don't like that word. I've never heard it before, but I'm having a visceral reaction to it.
Yeah, that's what Tesla calls it, as a frunk.
That's awful.
I like it. Front trunk.
No, that's terrible. I mean, yes, of course, we put words together in these ways, and
It's
that
a portmanteau.
It is a portmanteau, but I think it's terrible. I don't like it. I'm going on record. Tesla, you have a lot of great ideas. Frunk is not one of them. It's not.
Well, be sure to tell Elon.
That's right. Next time I get a chance to, pull Elon's ear my way. That's right.
Oh, yes. Flying out says bonnet. That's what it's called.
A bonnet. There you go. Got a bonnet and
a boot and a bonnet.
Got a bonnet and a boot. And then
fruit.
in Canada, you go oot and a boot.
Oh my god. Oh my god. The wedding I was in last weekend, the groom is from Canada, and so all of his family kept saying oot and a boot.
Boot, a boot.
And I was trying so hard to keep a straight face the whole time, but I would forget, and then because otherwise they sound very American in their accent. Sounds very, I don't want to say normal, but just like something I would never guess that you were from anywhere else, right?
Similar to what you're used to, yeah.
Yeah, and then all of a sudden they'd say, "Oh, sorry." I'm like, what? Sorry.
Mm-hmm.
What are you talking about?
A boot.
A boot.
A boot.
What are you talking about?
Hot Rod. No, we don't. That was all caps. Hot Rod's shouting.
Hot Rod shouting. They were from New Brunswick?
Yeah, it's the Atlantic Canada.
Yeah, it was
Not the
Atlantic
Western.
side.
Yeah, the Atlantic side.
Yeah.
The Atlantic side. That's what we will say. The Atlantic side of Canada.
Oh, frunk. Strangely suitable for
Safe.
work.
Suitable, safe for work. Suitable for work. Yeah. Frunk. I got the frunk. Everybody, you got the frunk.
Do you like it now?
No, I don't. I hate it. Really don't like it.
All right, Kiki. All right.
It is
Blair.
not. That is not what?
Frunk,
gotta
a
go.
trunk on the front end of a mid or
No.
rear engine car.
No. Do
I
you
think
see
I
the
have to-
top definition?
That's the top one.
No.
Uh-oh.
Not in my no. Oh, that's the top. But the one on the top.
On the top.
Oh, they have so two the when I opened it, the very top entry, not safe for work. Frunking on the dance floor. Frunk, second definition, to act very drunk when you have not consumed as much alcohol as you said. To act fake drunk. Fake drunk. Is that like that's fake news of the drunk drunk category.
Oh. Or when you eat so much you feel drunk.
You know what? Oh, it's Ian, 2005. I bet the frunk got voted way up by Tesla people.
I'm
really
sure
recently.
it did.
All recent votes by people who don't know what they're talking about. Who
I'm
are
okay with it.
Tesla fanboys.
Take back
there's
the
nothing
front.
wrong with being a Tesla fan person. Why is it only boys, Kiki? All right, I gotta go. I'm
I didn't
about
say
to
only
turn into a
boys.
pumpkin.
Did I say only boys? I didn't say that.
So good night, Justin. Good night,
Are you
Justin.
done? Okay.
I gotta go. I gotta
Do we
finish this
have-
project over here, but I will be back.
You have an
next
art
week.
show. When's your art show? Is it happening?
Yeah,
I
sometime
saw
in
you.
September.
Did you do your art? Did you do your art speak for your photo for your artwork?
Yeah. I said obfuscationist painter.
Great. Good.
I just left it at that.
Awesome. You'll have to let us know in September when your show is out.
It'll be the
Davis.
second Friday.
Cool.
Yeah.
Cool. All right. I will
guys
see
can keep going.
Blair.
I gotta
will
go.
see. We can go.
You guys,
Yeah.
no,
I gotta
chat
pack.
amongst yourselves.
Blair
gotta
has
pack.
to pack. She already said that she didn't want to hang out very late, so this is all good. It's
She
all
always
good. We
says
don't-
that though. You can't take that.
That's
like
not
you trying to say.
always.
That's
Sometimes
like how
I
you
have
say
fun.
goodbye at the end of the show, and then we keep going for an extra hour. You just
That's
ignore
not- Don't characterize me like that. Sometimes I stay and I have fun.
it.
Sometimes I stay.
Yeah, no, I agree. But you always say
No,
that
always.
you have to go.
No, not
I
always.
can't. I have this. I'm tired because in my life, or I have to get to sleep because
Hey,
of my
did
life.
I even play the tired card tonight? I did not,
She
even
has to
though
pack.
a
She
cat
said
threw
she has
up on me while I was sleeping last night. So
Oh,
I
no.
am
Oh,
tired.
that's terrible.
That's the worst thing to wake up to. You wake up to that.
Oh no. Another reason not to have cats. But I did have a cartoonish night like a couple nights ago where it started with the fish tank was making too much drippy water sound. So I had to go and like top off the fish tank. And then there was a cricket somewhere in the house that started. And if there's a cricket outside, it's like can be a little calming to hear crickets outside. When there's one in your room, it's loud and unnerving and you will not go to sleep. So then I went from dripping water to cricket to cat fight something outside with the it was like I was like, this is a joke. This is not really can't be all, like any one of those could like disturb somebody's night's sleep, but all three in the same night.
Yeah.
It's ridiculous. All right. Good night, Justin.
Good night,
Night,
Justin.
Justin.
Say good night, Blair.
Good night, Blair. Good night.
Good night, Dr. Kiki.
Good night. Good night, everybody. Thank you for joining us for another show. I hope you join us again next week. I'm so excited to talk to Expanse authors. This is going to be
It's gonna
so
be
fun. Yes. Have you guys watched it at all yet?
Yeah, I'm digging it.
Good. All right.
I've identified it. I found out how to watch it. That took a minute.
Good job for you.
Step in the right direction.
Yeah, you're going to be less
And
than
how do people find
informed
it,
for
Blair?
the interview.
No, I'm gonna watch some before the interview for sure.
For sure. For sure.
For sure.
For sure. All right, you guys, for sure. We'll be back here next week. And I can't wait to hear about everybody's eclipse stories. Blair and I will have fun eclipse stories to tell everybody. And yeah, we're looking forward to it. I hope you have a wonderful weekend and happy eclipse, everybody.
Happy eclipse.
Bye.